Hello, good evening, everyone.
Good evening, ma'am.
So, this is your week 7 open session. So, in today's session, we have to study about the probability. So, earlier to that, in week 5 and week 6, you have studied about the permutation and combination, circular permutation, and how we arrange the things. Okay, these things we have covered up to week 6. So, these concepts will be used in week 7 and 8 also for finding out the probabilities. So my screen is visible to everyone.
Yes, ma'am.
Yes, ma'am.
Okay. Yeah. So for studying the probability, we have to study for some other things also, like what is a random experiment, what is an event, what is a sample space, how what is the event, and how two events are independent and equally likely events. So these topics we have to study for studying the probability. Okay. So the first very basic thing that we study when we hear about probability is that uh, probability is something which gives us the chance of something happening, right?
Yes.
Yes. So suppose in some practical scenarios, suppose we have a match and in the toss we are guessing that there is 50% chance that India will win the toss. And in some other example, we can take that if you have a question, multiple choice question, and there are four options for that question, and we are saying that, okay, you are guessing that option number A will be correct option. Okay, so let me write these examples also. So suppose there is a 50% chance that India will win the toss. Second example was that our guess is answer A is the correct option. We
But
guess that option A is correct. Okay, we are just guessing these things. Okay, next we say that there are 50% chances or 30% chances that it will rain tomorrow. Okay, so next one is there is suppose 40% chances of rain tomorrow. Okay, and suppose in the election we just assume or we just say that probably party XYZ will win in the election. Okay, so again we are just guessing that party XYZ will probably win the election. Okay, now in these statements that I have written here, you can see there is, we are talking about the chance, okay, that there is a 50% chance that India will win the toss, or we are just guessing that option number A is correct, okay, again, or we are saying that the probability that party XYZ will win the election. So you can see that in all these statements, there is some element of uncertainty, right? We are not 100% sure that these things will happen. We are not 100% saying that it will rain tomorrow and the party XYZ will win. We are just guessing these things. Okay, so we are uncertain about these things. Okay, so the element of uncertainty is there. Okay, so now I can write some formal definition, which is that the determination okay, the determination of the likelihood or the chance or chance that an event will occur is subject matter of probability. Okay. Okay. So in layman terms, we say that it is probability is something that gives us the chance of something happening. Okay. Now for stating the probability, we should know what is a random experiment. And further, we will study about the what is the sample space and events and all these things. Okay. And for studying the random experiment, first we should know what is the experiment. So what do you understand by a experiment? What is experiment? Anyone?
When we toss, this is an experiment. When we get outcomes
Hmm.
randomly, we toss.
Yeah, so we can say that an experiment is any process that produces some observations or some outcomes, right? So we can say that an experiment is any process, okay, that produces observation or outcome. Okay. Now we can see some experiments. So suppose we have two persons, A and B. Okay, so suppose we are doing an experiment first, in which what we are doing, the both person A and B have one glass of water. Okay, and we are they are mixing 1 spoon of sugar in this. So we can assume, or we can say that same kind of result they both will get. They have one glass of water and they are mixing 1 spoon of sugar. Okay, or we are saying that we have two H2 plus O2. So that will definitely give us water, right? This is the chemical equation for water, right? Okay. Now, next example, we can take that both person A and B have a coin. Okay. This is our second experiment, let's say, and this is the third one. So suppose they both are coins, and person A have one coin and B has one coin. Okay. And they are conducting experiment. They are flipping the coin. Okay. So we know that in that case, maybe head or tail will come, right? But we don't know what exact outcome they will get. Okay, maybe A is getting head or B is getting tail. Maybe A is getting tail or B is getting head. Okay, so we are not sure. We are we are uncertain about what out of these two will come exactly. So here we have seen three different kinds of experiment. So here we can see in the first and second, so these two are deterministic type of experiment, because here we already know what will be our outcome. Okay, so always when we have two H2 plus O2, it will always give us water. Okay, and here also, like if you have 1 glass of water, we are mixing a spoon of sugar in it, so we will get some solution of it. Okay, but here in the third example, you can see that we know that head or tail are the possible outcomes that we can get. But what exactly you will get, that is not sure. Maybe you are getting head or maybe you are getting tail. So this is something we can call a random experiment. Okay. So the first two are deterministic kind of experiment. Okay, where we already know the outcomes. Okay, but in the third one, you can see it is a random experiment. Okay, so now we have to see what is a random experiment exactly. So can you guess what will be a random experiment?
When we don't know about what can be outcome.
Hmm.
Exactly.
Yeah. So random experiment is something where we know the possible outcomes. Okay, possible outcomes we know, but what exact outcome we will get out of those set of possible outcomes, that is uncertain, right? So I can write that random experiment is an experiment where outcome is not predictable with certainty, right? But we know the possible set of outcomes, right? So this is the definition of random experiment. Okay, so it is saying that we know the set of possible outcomes, but what exact outcome you will get, that is not predictable with certainty, right? So the very basic example of coin. Okay, so we know that either head or tail we will get, but what exactly you will get, that is not certain. Okay, next, like you can take the dice example. So if you are throwing a die, right? So we don't know that, like we know that numbers from 1 to 6 you will get. Okay, up to 6. These are the possible outcomes, but we don't know what exact number will come. Okay, so let's take some more example of a random experiment. Okay, so the first one is, suppose we have multiple choice question in which we have 4 options. Okay, so guessing answer to a 4 options multiple choice question. Okay, so suppose A, B, C, D are 4 options. So we know that the outcome of this experiment will be A, B, C, and D, right? But what exact option is correct? Exactly that we don't know with certainty, right? Next one we can take that we have 6 students, suppose A, B, C, D, and A, B, C, D, E, and F. Okay, and they finish a race. Okay, so in what order they finish a race? Okay, so order of finishing a race with 6 students. A, B, C, D, and E. A, B, C, D, E, and F. Okay. So what can be the possible outcomes in that case? The 6 people, 6 ranks were there. First, second, third, fourth, fifth, and sixth. Okay, can you tell me what will be the total number of possible outcomes in that case?
Six factor.
Yeah, 6 factorial. Okay, so it is just like we have 6 elements and we have to arrange 6 elements. So that can be done in 6 factorial base. Okay, so the outcomes will be something like A, B, C, D, E, F, or maybe B, A, D, C, F, E, or maybe A, C, D, E, F, B. Okay, something like this. So these 6 factorial arrangements will be the outcome for this experiment, right? Now next we can see tossing two coins, right? Okay, and noting their outcomes. So in that case, what will be the outcomes? Outcome will be like head, head, tail, head, tail, tail, and head, tail, right? So if you're tossing 2 coins, your outcome will be like this. Okay. Or next you can take that. So these points are clear to everyone up to this example.
Yes.
Yes, ma'am.
Okay, next one, the example we can take is that we have to throw a dart in a unit square. So we are noting the point. Where it lands. Okay. So we have a unit square, suppose. So if I draw it on the axis, it will be something like this. Suppose this is our 0, 0. Okay, and this will be 1, 0, 1, 1, and 0, 1. Okay, so this is the unit square. So the sample space, okay, the outcome will be like the points in the square, in this square only. Okay, so the collection of all the points in this square will be the outcomes.
Ma'am, just a question. So
Hmm.
it can also lie on the square, right?
Yeah, like border points were saying.
Yeah, yeah.
Yeah, that is also included. All the points in this square are included. Okay, inside it or on the lines also. Okay, so the outcomes that we are talking about is nothing but the sample space, right? So next thing we have to study is the sample space. So sample space is generally denoted by S, or some writer may denote it by this symbol also. So sample space, what is a sample space?
The number of
The space of
outcomes.
possible outcomes.
Sorry, what?
The space of
Total
possible.
number of possible outcomes.
Okay, so you are someone is saying that total number of possible. So we will not say the total number. It is actually the collection of all the possible outcomes. Okay, so if you are saying the number of outcomes, so that will be the cardinality of your sample space. Okay, but sample space is basically the collection of all the possible outcomes. Okay. So in the first example, was guessing answer to a four options MCQ. Okay, so here what will be your sample space? This A, B, C, and D, right? So in that case, sample space will be all the four options A, B, C, and D, right? In the second example that we have taken is that order of finishing a race with six students. Okay, so six students are doing a race. So these six factorials arrangement of these six students will be the total, will be the outcomes or the sample space. Okay, so this is basically the sample space only. Okay, so there will be six factorial arrangements, right? So all these six factorial arrangements will come into the sample space. So it will be something like A, B, C, D, E, and F. This is one possible arrangement. Next, suppose B, A, C, D, F, E, maybe this. Okay. So in this way, you will have six factorial arrangements that will be your sample space. In the next example, we have taken the tossing of two coins. Okay, so this is your sample space. Okay, head, tail, tail, and head, tail. In that case, in that example, this is your sample space. Okay, because these are the only possible outcomes for the corresponding experiments. Okay, next we have taken this one, that we are throwing a dart on a unit square. Okay, so in that case, the collection of all the points on this unit square. Okay, so the sample space will be the points. So we can write it like x comma y. Okay, where condition is that x will lie in 0 to 1 and y will also lie into between 0 and 1, right? So all the collection of all the points will be the sample space for this fourth experiment. Okay, that will be your sample space. Is it clear to everyone? Now everyone knows what is the sample space.
Yes.
Okay. Next we have to see is what is the event. So what do you understand by event? Anyone?
Event is a subset of sample.
Sample space. Yeah. So event is basically subset of sample space, or we can say that collection of some outcomes, some or all outcomes. So an event is a collection of outcomes. Okay, and also that an event is a subset of the sample space. Okay, so even suppose we are taking an example of tossing a coin, tossing two coins. Okay, so tossing two coins. And we are defining the event. Okay, so in that case, the sample space will be this head, tail, tail, head, and head, tail.
Oh.
Okay, and we are defining the event E that head comes or head appears in the first toss. So what outcomes it will contain?
Head, tail.
Yes, head and head tail. Okay, so this is one event. Now we can define another event also. Suppose this is E1. Now if we define another event E2, that head appears on the second toss. In that case, E2 will be
Head, tail, head.
head and tail head, right? So these are the example of event. Okay, you can take other examples also, like for a die. So if you are throwing a die, okay. So this is your example one. Now second example, throwing a die. Okay, sample space will be 1, 2, 3, 4, 5, and 6. Now we are defining an event that even number appears. Okay, so even number appears, which means uh, even will be, so it will contain the outcomes 2, 4, and 6, right? Similarly, you can take another uh, event also that odd number appears. Okay, in that case, your E2 will be 1, 3, and 5, right? Is this clear to everyone?
Yes, ma'am.
Yes, ma'am. Yeah. Okay, so these are the events. So in this way, we define the events. Okay, we can define the events in these examples also. So, like in the last example, we can say that the dart falls into the region where x is suppose 0 to half and y is also between 0 to half. Okay, so in that case, suppose your this is some event, okay, and x comma y such that x falls between 0 to 1, 1 by 2 and y also falls between 0 to 1 by 2. Okay, so this is your event in that example. Okay, now we know that sample space and event both are sets, right? Okay, a sample event is a subset of sample space, and subset is also a kind of set, right? So we can perform the operations of set theory. If you have studied set theory, we know that we can perform union, intersection, complement, these kind of operations we can perform on the sets, right? Am I right or wrong?
Yes,
Yes.
ma'am.
Okay, so I can write that event is basically a set. Okay, so we can perform all set operations. Okay, which means union, intersection, and complement. Okay, on event. Okay, so union we represent like this, that we have two events E and F. So E union F and E intersection F. So what do you understand by E union F and E intersection F?
In A union F, all the elements of E and F come.
Hmm.
So here only the intersection come in second.
Yeah. So in union, if we have these two sets C and F, so if we write the union or union set of E and F, so it will contain all the outcomes which are in E and F, right? And in intersection, we take only those outcomes which are common in both. Okay. And what E union F represent that either E or F will occur, or F will occur, right? An intersection, which means both E and F will occur, right? Okay, so basically we can say that this union means or, and this intersection is and. Okay, so whenever in the question you say the question is something like two events like E and F occurring together, so it will be an intersection. And if it is like that event E or F occurs, then it will be union. Okay, so now we can take example of it. So here you can see that in the first example we have E1 and E2. So here if we have to find E1 union E2, what it will be?
Only HH. Only okay. All the four outcomes.
Yeah.
You mean
So
all
if
the
you are
three outcomes? Sorry, all the
yeah,
three.
all the three outcomes. Okay, so E1 union E2. So in the first one, first example, E1 union E2 will be head, comma, tail, head, and tail, right? So only H is common in both. Okay, so in union, we have to take all the outcomes which are there in E1 and E2. Now, if I have to take intersection of these two, then E1 intersection E2, then we have to take that element which is common in both. So it will be HH only. Okay, now similarly, in the second example, we can see that even is 246, which is even number. Okay, and E2 is odd number appears, so it is 135. So if I take union, okay, so it will be all the numbers. 1, 2, 3, 4, 5, and 6. Okay, and if I take intersection, then
Null set.
Null set.
yeah. So even intersection E2 is, you can see that it is a 5, which is a null set. Okay, so next we have to see is the null set only. So what is a null set? Or we can say null event also. So null event we will say here in terms of probability. So what is a null event? So null event basically a event which do not have any outcome in it. Okay, so it is an event without any outcome. Okay, so it will be represented by 5, this symbol. Okay, so here we can see even intersection E2 is a null event, right? Now, next is what is a disjoint event? What is disjoint events?
When two events are independent of each other.
Independent. So independent and disjoint are same or they are different?
I think. So if event E doesn't disturb the occurrence of the event F, and either way.
Yeah, so if occurrence of event E does not affect the occurrence of event F, then they both are independent, but they are not disjoint. Independence and disjoint, these two are different things. So disjoint is also called as mutually exclusive events. Okay, so disjoint is something like if the intersection of two events is a null set. Okay, so if you have two events E and F, okay, so if E intersection F is a null event, okay, then E and F cannot occur simultaneously, right?
Yes, ma'am.
Okay, and then we say that E and F are disjoint or mutually exclusive events. Disjoint, or we can say mutually exclusive. Okay, so which means that if you are taking E and F, so it is a null event, which means E and F have nothing in common. Okay, so that is why E intersection F will be a null event. Okay, so they do not have any element common between both the two. Okay, so if one event is occurring, then other event cannot occur in that case. So you can take that if head is occurring in the first toss, then tail cannot occur in that first toss, right? So if E contains your head and F contains the tail, then E intersection F will be phi, right? Okay,
Yes,
so these
ma'am.
kind of events are disjoint events. Okay, which do not have anything common. Okay, next one is that the complement of a event. So what do you understand by complement of an event?
That event doesn't occur, right?
Mhm. So if you have an event E, okay, then how do you represent complement of event E? It will be E and this small c at this side. Okay, and this E complement consists of all the outcomes. All the outcomes in sample space, which sample space is which are not in E. Okay, so sample space you have, and you have a event E. Okay, so all the remaining events which are not in E but in the sample space, Okay, that is your E complement.
So, in the set theory language, it's E minus S, right?
S minus E.
S minus E, sorry, yeah.
Yeah, it is S minus E. Okay, so from all the events, from all the outcomes of the sample space, if you subtract those outcomes which are in the event E, okay, then you will be having the E complement. And if I talk about the complement of the sample space, then what it will be? Complement of the sample space?
It will be null set, right?
Yeah,
Null
it
set.
will be 5 because in sample space we have all the outcomes, all the possible outcomes. So in complement we have nothing. Okay. Now next we can have is that subsets. So subset, which means that we have two events, E and F. Okay, so if all the outcomes of E are also in the F, then we say that E is contained in F or E is the subset of F. Okay, so if all the outcomes in E are also in F, okay, then E is contained in F, okay, or E is subset of F. Okay, and how do we represent it? It is represented like this. Okay. So if you have studied set theory, you will be understanding all these things, what I am doing here. Okay. Now next is that we can represent these relationships of events through a Venn diagram. Okay, so next we have a Venn diagram. So why do we use this Venn diagram? So it is a graphical representation. Graphical representation that is useful for illustrating logical relations of the events. Okay, so this is called Venn diagram. Okay, so in Venn diagram, we have sample space and we have events. Okay, so sample space is represented by a square, right? So this represents your whole sample space S, and suppose we have suppose three events E, F, and G. Okay, so we can have events like this, that this is E, this is F, and this is G. E, F, and G. Okay, so now you can see that this portion, so this yellow portion is representing what in terms of your union and intersection?
Intersection,
E.
intersection F.
Yeah, so this is E intersection F. Okay, so this yellow portion is E intersection F, right? Similarly, this green one.
If E intersection G.
Yeah, that would be E intersection G. Okay. And if I take this one, it will be F intersection G, right? Now this reason, this one, this is actually common in all E, F, and G. So it will be E intersection F intersection G,
Intersection
right? So this is the portion which is common in all the three events. Okay, now if what if these two events are not they are disjoint? Suppose, okay, if E and F are disjoint, then we can represent them like this, that E, this is suppose E, and this is suppose F. Okay, so these two are disjoint, they have nothing in common. Okay, so we will draw them separately. Okay, and if you have to draw a union, then suppose I have to draw a union. Okay, union of E and F, then it will be this portion. Okay, E and F. Okay, so this is representing the E union F, right? Okay, now the next, if I have to represent this condition subset when E is contained in F, okay, then how can I draw it? So it will be like this. Okay, suppose this is your set F and all the elements of E are contained in F. So this is your E. Okay, now in that situation, E is subset of F. And here E and F are disjoint. Okay, so in this way, we can represent our even sample space in the graphical way, that is called Venn diagram. Any question in this part? Is this clear to everyone?
Yes, ma'am.
Okay. So next we have to see what is the interpretation or some definitions of probability. So basically we have three main interpretations of probability. Okay, so the first one is the classical probability or theoretical probability. So this is classical. Also, it is also called a priori or theoretical. Okay. So according to this definition of probability, suppose we have a sample space S. Okay. S is a sample space. Okay. And in this S sample space, we have N equally likely events. Total N equally likely events. Okay. Now, what is equally likely events?
Probability of happening those events are same, right?
Same. Yeah. So equally likely events are those which have same probability of happening. Okay. So in the classical probability, we assume this thing that we have n events which are equally likely. Okay. Sorry, not events. It is outcomes actually. We have the outcomes which we have in the sample space. Okay, those are equally likely outcomes. Okay, now we have an event E. Okay, we have some event E, okay, which consists m outcomes. Out of those n, okay, so it contains m outcomes in total, okay, out of these n. So the probability of happening of E, it will be m divided by n. So m is the favorable number of outcomes which are contained in this E, and divided by n. So n is all the outcomes. Okay. So the assumption here is that these n outcomes are equally likely. So this is the definition, classical definition of the probability, which is we call that favorable outcome divided by the total number of outcomes. Is this clear to everyone? Okay. But we should remember this thing always, that when we have to use this kind of this formula of probability, it is used when all the n events are n outcomes are equally likely. Okay, then only we can use this formula. Okay, so for example, when we are throwing a die or a coin, we know that in the case of coin and the die, we have equally likely events. Both head and tail have equal probability of being occurred. Okay, and in die also, all the numbers from 1 to 6 have equal probability 1 by 6 of occurrence, right? So they are equally likely events. So that's why we can use this formula there, favorable outcomes divided by total number of outcomes, right? Next, we have relative frequency.
Hello, ma'am.
Yes.
Ma'am.
Hmm.
Will they give equally likely outcomes in the question, or do we need to find it out?
So it depends on the question. Maybe it is mentioned that the events are equally likely, or maybe it
Okay.
is understood. Like, for example, if you are given a fair coin, okay, then it is
Okay.
understood that the occurrence of both head and tail have the equal probability.
Okay. Okay. Okay.
Okay, otherwise, if you have some different scenario, it will be mentioned in that case.
Okay. Okay. Thank you. Thank you.
Okay, next method or the next definition that we have is the relative frequency. Which is also called a posteriori or empirical method. Okay, so in this definition, the probability of an event in an experiment is the proportion, or we can say fraction of the times the event occurs in a very long, or you can say it that theoretically infinite series of independent repetitions of the experiment. Okay, so in other words, we can write, in other words, if you have an experiment event E, okay, so NE, so this will be representing is the number of times E occurs in N repetitions of the experiment. Okay, and in terms of probability, we write that probability of E will be equal to number of times event E occurs divided by n, where n is tending to infinity. Now let's understand what this definition says. So suppose we have a coin, okay, and we are doing an experiment. We are throwing a coin, and we are saying how many times head appears and how many times tail appears. Okay, and we want to know this probability. So what we are doing, we are conducting this experiment several number of times. Okay, so maybe at first we have done this experiment for suppose 10 times. So we get tail, head, uh, suppose tail, 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 then head, tail, head, tail, like this. Okay, we are conducting this for 10 times. Okay, so maybe this is something you got. So if you're talking about the probability of occurrence of head, then we have 1, 2, 3, 4 times. Okay, out of 10 times, out of 10. Okay, so this will be the probability for E. Okay, now next, suppose we are conducting the same experiment for 20 times. Then maybe you are getting some different set. Okay, like this up to 20 times. Okay, so what we are doing in this, we are saying that n is tending to infinite, which means that we have to conduct it for a large number of times. So maybe we are conducting this for 1,000 times. Okay, maybe we are conducting the experiment for 1,000 times, and then we are getting the head, suppose for uh, 400 times. Okay, where we can see that we have done this experiment for 1,000 times. Okay, you can see that n is tending to infinity in this case. Okay, so this is what this experiment says, what this definition says. So what we are doing, we are conducting this experiment several times. So n is equal to 1,000 here. Okay, and then we are counting the frequency of that event. So you can see if you are talking about head, so I am supposing that the frequency of occurrence of head is 400. Okay, so in that case, the probability will be 400 divided by 1,000. Okay, so this is, we can say, the drawback of this definition also, because, because practically it is not possible to repeat the trial a large number of times. Okay, is this clear to everyone?
Yes, ma'am.
Okay, that is why the name of this method is relative frequency, because what we are doing, we are counting the frequency of that event. Okay, next one is
Ma'am, can you
what?
oh,
Are you saying something?
some examples related to this topic?
See, in this, what you have to do, you can take the example of die also, or whatever you can take. You just have to see that you have to repeat the experiment. Okay, the trial should be a large number of times. Okay, so here you are flipping a coin. Maybe you are throwing a die. Okay, so you are doing this experiment for a large number of times. Okay, which is also a drawback of this method, because in practical scenario, you cannot perform experiment 1,000 number of times,
Yes,
And
ma'am.
then you just have to count suppose in that particular event, I have taken the occurrence of head. So I am counting the frequency of head here. Okay, so let's suppose that we have got head 400 times. Okay, similarly, you just have to count the frequency of that event. Okay, so the frequency will be in the numerator and denominator. In denominator, you just have to write the number of times you have conducted that experiment. Okay. So generally,
Okay.
we do not use this method because of the drawback.
Okay.
Next one is that subjective probability. So in the subjective probability, as the name suggests, so in this case, suppose here we have 5% and we are asking to them what are the chances of that it will rain tomorrow. So someone is saying that there are 30% chances. Other person is saying that there are suppose 40% chances, or someone else is saying that 50% chances. So it depends on the it may differ from person to person, okay, because it is subjective in nature, okay, because it depends on the belief of that person. Okay, so if I talk about the definition of this, so it is the probability of an event is a best guess in that case, okay, is a best guess, okay, by a person making the statement. Of the chances that event will happen. Okay, so it may differ, and the probability measure an individual's degree of belief in that event. Okay, so this is the definition for the subjective probability. Okay, so as you can see, as the name, it has subjective, so it is subjective in nature, which means it may vary from person to person. Okay, it depends on their belief, their guess. Okay. Apart from these definitions, there are some axioms of probability, okay, that we use most of the times. So there are some probability axioms which will be used. Okay, so the first one is that probability always lie in 0 to 1. Suppose E is any event, okay, so the minimum probability can be 0, maximum it can be 1, right? So this is the range for the probability, right? Next one is that probability of the sample space is equal to 1. Okay, now what does it mean? So it means that the outcome of the experiment, the outcome of the experiment will be an element of sample space. Element of sample space S with probability 1. Okay, so that is for sure that whatever outcome you are getting, that will be in the sample space, right? That's why probability of the sample space is equal to 1. Okay, that is for sure. Next we have is that if you have a sequence of mutually exclusive or disjoint events, okay, so for a sequence of mutually exclusive or we can say disjoint events. Okay, suppose even E2 up to like this. We have this series or sequence. Now, if you have to find the union of these events, okay, union of these EIs, where I is going from 1 to infinity. Okay, we have to find the probability of these. So we know that these events are mutually exclusive or disjoint. Okay, so that will be equal to the summation of their individual probabilities. Okay, summation of the individual probabilities, where I is going from 1 to infinity. Okay, now if I generalize, okay, this is the general formula. Okay, if I take it for two events only, okay, so if you have two events, E1 and E2, okay, so union of E1 and E2, E1 union E2, okay, and we have to find the probability of this E1 union E2. So that will be equal to the summation of their individual probability, which means probability of E1 plus probability of E2.
Ma'am,
Okay.
just a quick question. Like, can we write this in the form like P of E1 plus E2 equals P of E1 plus P of E2?
Sorry, what?
So can we write this in the form of P of
Hmm.
E1 plus E2 equals P of E1 plus P of E2?
No, because see, these E1 and E2 are set. Okay, so whenever we have set, we can either write E1 union E2, or we will be writing E1 intersection E2, because these two are sets. So these sets may contain many elements. So you cannot write that you are adding to set. You can take either union or intersection. And here you can see that these two are probabilities, which means they have some number between 0 to 1.
Yeah, right.
Okay, so that is why we are here we are writing addition. Okay,
Okay.
but here we cannot write the plus sign.
Okay. Okay.
Yeah. Okay, so this is for the disjoint events only. Okay, and we will see this formula addition rule for if you don't have the disjoint events. Okay, so this is for two events only. If you have two events, okay, where E1 and E2 are disjoint. Okay, here E1 and E2 are disjoint. Okay, we have some other general formulas also. So probability of E complement, if I have to find, that is equal to 1 minus probability of 1 minus probability of E. Okay, how I can prove it? We have E and E complement, right? So these two E and E complement will be disjoint, right? E and E complement are disjoint. Or we can say mutually exclusive, right? Okay. So if I take E union E complement, it should be equal to what?
1.
We are taking the sets and not the probability.
That would be a null set, right?
Null set.
No.
E.
It would be none.
It
It
will
won't
be
be
No,
E.
no,
no.
no. E and E complement both will come.
Yeah, so that would be sample space. No?
The whole sample space.
Yeah, that will be equal to sample space. Okay, we have taken the event E and its complement. So if you take union, it will be equal to the sample space. Okay, that we know. Now, if I take probability at both the sides, that probability of E union E complement is equal to probability of S. Okay, so we know that probability of S is equal to 1, that we have seen earlier, this point. Okay, so I can write that probability of S is 1. Now E and E complement are disjoint events. So I can write that probability of E union E complement will be equal to probability of E plus probability of E complement. Right? Now from here we can conclude that probability of E complement will be equal to 1 minus probability of E. Right? Okay. Also, if I talk about the probability of a null event, what it will be?
Zero.
It should be 0, right? And S complement is equal to 5, right? That we have seen earlier also. So probability of S complement, okay, we can prove this also. Probability of S complement will be equal to what? 1 minus probability of S according to this formula, right? Okay. And 1 minus probability of S is equal to what? It is equal to 1. Okay. So 1 minus 1 will be equal to 0. So now you can see that probability of S complement will be 0. Okay. And S complement is a null event. Okay. And probability of null event is 0. Okay. Now you can see that all these points are verified. Okay. So we have seen this union formula here for disjoint events. What if these events are not disjoint? Okay, they have something in common. Okay, so we have to see the addition rule here. Addition rule of probability. So if you have two events, E1 and E2, suppose. So then what will be the probability of E1 union E2? Okay, so that will be probability of E1 plus probability of E2 minus probability of E1 intersection E2. Okay, where you can see that E1 and E2 are not necessarily disjoint. Okay, so from this formula also you can see, so this is the general formula. Okay, this is the addition rule. So if you have E1 and E2 disjoint, okay, if in case E1 and E2 are disjoint, then you can see that E1 intersection E2 in that case will be equal to 0, right? Also, sorry, it will be equal to 5. And the probability of E1 intersection E2, that will be equal to 0 in that case. Okay, so if you put this value here, this term will be 0, right? So then you will get the formula for disjoint event, okay, which is equal to the like summation of the individual probabilities only. Okay, so when you have two events disjoint, the intersection part will become 0. And if they are not disjoint, if you don't have disjoint events, this will be your formula. Okay, you have to take individual probability, summation of individual probability, and then you have to subtract the intersection part from it. Okay, now let's see a question. So suppose we have to find we have a deck of cards, 52 cards. Okay, and you have to find the probability that the card we have drawn one card, so it is either red card or a queen. So basically we have to find the probability that the card drawn is either red or a queen. Okay, so suppose we have two events in that case. So A, suppose, is representing that the card is a red card. Okay, and event B is representing that the card drawn is a queen. Okay. Now, if I find the probability of A, which is drawing a red card, so what it should be?
1/2.
26.
1/2.
26 by 52.
Yeah, 26 divided by 52, which is equal to 1/2. Okay, so total 26 cards are there, which are red in color. Okay, and total card we have is 52. Now, if I find the probability that the card drawn is queen, so then it will be
4 by
4 by
4 by
52.
52.
113.
4 by 52. Okay, so total 4 queens are there in a standard deck of cards. Okay, divided by total number of cards. So 4 by 52. Now we have to take probability of A intersection B. Okay, so A intersection B, which means that the card is red also and it is a queen also. Then
2 by 52.
it will be 2 by 52. Okay,
Yeah.
because we have uh, 2 red queens and 2 black queens, right? So 2 red queens will be there. So 2 divided by 52. Now we have to find the probability that
Ma'am,
the
once could you explain once again P of A?
intersection B, huh? Okay, so intersection,
Yes, ma'am.
okay, so intersection represents that both the events will occur. Okay, so probability A intersection B represents that both A and B occur, which means A is a red card, that the card drawn is red, and B is that the card drawn is queen. Okay, so we have to find the probability that the card that we have drawn is red also and queen also. So total red cards are 26 and total queens are 4, right? And we know that out of these 26, 2 queens were there. Okay, total 4 queens we have. Okay, in which 2 queens are red in color and 2 queens will be black in color. Okay, so that's why the common is that 2 red queens. So 2. The favorable number of outcomes will be 2. Now is it clear?
Understood, ma'am. Yes, ma'am.
Okay. Now we have to find the probability that the card drawn is either red card or a queen. So either or, which means we have to find the probability of A union B. Okay, so union tells us that either A occurs or B occurs. Okay, so that we can find by using the additional rule. Addition rule. Okay, so which is probability of A plus probability of B minus probability of A intersection B. Okay, and we can see that A and B will not be disjoint here. Okay, we have something in common between A and B. Okay, so probability of A is 26 divided by 52 plus probability of B is 4 divided by 52 minus this is 2 divided by 52. Okay, so when you solve it, it will be 7 divided by 13. Okay, is it clear to everyone now?
Yes.
Yes, ma'am.
Yeah, so this is how we use the addition rule of probability. Okay, so now do you all understand when we have to use union and when we have to use intersection?
Yes, ma'am.
Yes, ma'am.
Okay, so intersection when both the events are occurring, and in union is when either of the events is occurring. Okay, also let me give me a quick revision for the deck also, cards. So we have total 52 cards in a standard deck of cards. And in these 52 cards, we have 4 suits. Okay, diamond, which is like this, and heart, like this. Then we have club and spade. Spade is something like this is club, and spade is something like this, right?
Yeah.
Okay, so these 4 suites we have in a standard deck of card, and each suite have 13 cards. Okay, and what are those 13 cards? So these 13 cards are, one is ace. Okay, then we have 2, 3, 4, 5, 6, 7, 8, 9, and 10. Then we have jack, king, and queen. Okay, and these jack, king, and queen are also called as face card. Okay, so now is it clear to everyone?
Ma'am, one will be also there.
No, one
Or
is
that
not there.
ace, that is ace.
Only ace.
Yeah, only ace, one we don't have.
Okay.
Okay, ace, 2 to 10, then jack, king, and queen. Okay, so these are the cards which you have in all these suites. Okay, diamond, heart, club, and spade. Also, these two, these diamond and heart, these two are red in color, and these club and spade are black in color. Now I hope it's clear to everyone.
Yes, ma'am.
Okay. So now you can solve the questions regarding the cards and all. Yeah, so these topics, these things we have in week 7. Further topics of the probability like multiplication rule, Bayes theorem, all these things you will be studying in the week 8. So if you have any doubt, you can ask.
Ma'am, I placed question in chat box. I'm not finding the intersection, then how I will find this? I can find the probability of red and probability of 5 cards, but I'm not finding the intersection. Then how I will find this?
Sorry, can you repeat your question? I'm not able to understand what you're saying.
Yeah, can you see questions in chat box?
Okay, 1 minute. Your question is this: find the probability of selecting a red card or a 5 from a deck of 52 cards. This is your question, right?
Yes.
Okay, so we have 2 events. Okay, one event will be that selecting a red card. Okay, so red card are total 26 in
This
number.
is this is disjoint event or not?
Okay, wait. And then next event is that selecting a card of 5. So it will not be a disjoint event because we have 2 5 of red color in heart and club suits. Sorry, in heart and diamond. See. So in the previous question, we have taken a red color. Okay, and here the question will be the B you can take is the card is 5. Okay, card is a 5.
Ma'am, are you writing, ma'am?
Uh, yeah, wait.
I have a doubt here because is it not something to do with it's they said selecting a red card RFI, so the red card is actually 26 amp, right?
A red card are 26 in total.
Yeah,
Okay,
but it's
and the
R, am I right? It's not it's not a card of red. They're asking. It's a red card or a 5 from a deck.
Yeah, so that is why you have to find the probability of A union B in that case now. So card is 5. Okay. So here, red card, you have probability of A will be 26 by 52 only. The
Yeah.
probability of B, which is the card is 5. So that will be 4 divided by
4
52
divided.
again, because we have 4 cards of 5 in total, right? So similarly, values are same. Again, you have to find the card is either a red or a 5, right? So either or, which means you have to find the probability A union B. Okay, now you have to find the intersection part also. So A intersection B. So which means the card is red also and a 5 also. Again, it will
Can
be
you
2
can you
divided by
repeat
52.
how 4 came? There
See,
is a 5 card, but you wrote 4.
uh, see. 5 is the number, right? Like card of 5, but we have 4 cards of 5. So this is the like collection of 13 cards, right? And this will be in each suit, in diamond also, in heart also, in club also, and in the spade also. So that's why you have 13 plus 13 plus 13 plus 13, total 52 cards.
I
So
think
5 number we take from diamond, heart, club, and spade.
Yeah, so total one
Okay.
5 card is there, one here, one here, and one here. So total we have 4 cards. The number of cards is 4 of 5. Okay, and we have to see those cards which are red in color and 5. So that will be in the diamond and heart only. So we have 2 cards which are 5, but in red also in color. Okay, so the intersection part will be containing 2 elements. Okay, so A intersection B will be 2 by 52. So again, same answer you will get. Now is it clear to you?
Yeah. Yes, ma'am. Thank you. There was confusion in language. That's I was not understanding.
Yeah, 5 is like the card of 5. Okay,
Yeah,
5.
I was thinking the 5 card.
No, it's not the number of cards 5. Yeah, any question, any doubt?
Sorry, I just want to clarify. So this is a summary session, right?
Sorry?
This is a week summary session
Yes.
because I couldn't join for a long time. So I'm not able to keep track of the sessions. I'm sorry for that.
Yeah, it's for it's an open session for week 7.
Thank you.
Yeah, anyone having any doubt?
Ma'am, when will we solving the practice assignment for this week?
Okay, we will be having a doubt session
Okay.
on Tuesday. Okay, so there will be solving the questions.
Okay, ma'am. Okay. Thank you.
Ma'am, can you suggest which book I should purchase, 4th edition or 10th edition, which mentioned in the course? Can you explain about books?
Okay, whatever book you can take, it's not like there will be some updated version of it. So whatever is suitable for you, you can take.
So I was asking that which is what is difference between 4th edition book and 10th edition book? There is any difference or both books are same?
Some things will be updated only. It's not like that entire content is changed. Only few things may be extra in the latest edition. But you can take any one of these.
I search on Google, then I find out the 4th edition book is for basic and 10th edition book for advanced.
Yeah,
And there
yeah,
is
that is
also
what
many practice.
yeah, some questions, some things will be extra in the latest edition. But for this course, if you study the basic also, then it will be sufficient for you. It's your choice. You can take any of the book. Anything else? Okay, otherwise we can end the session. Thank you everyone for joining.
Thank you.
Thank you.
Thank you, ma'am.
Thank you.
Ma'am,
Yeah.
I have seen a formula where P of A intersection B is equal to P of A times P of B. Could you just explain what?
Yeah, that is independence case. So these things are not covered in this week, so it will be covered in
Okay,
week
okay,
8. So yeah,
okay,
that's
ma'am.
why I have not taught
Okay,
in this
okay. I
session.
haven't. Sorry, sorry for asking.
No, it's okay. So A intersection, probability of A intersection B is equal to probability of A into probability of B. That is true, but for that case only when A and B are independent events. Okay, and when
Oh,
these two events are disjoint, then the probability of intersection becomes 0.
yes, ma'am.
Okay, so independence, which means that if you have two events which are independent, which means the occurrence of one event does not affect the occurrence of another event. Okay, so suppose you are throwing a coin 2 times. Okay, so these two trials are independent of each other. Okay, so maybe in the first toss you are getting a head. Okay, that is independent from the outcome of the second trial, right?
Yes, ma'am.
Yeah, so these kind of events are independent.
Ma'am, can you define the replacement or without replacement? Replacement means we are removing these cards we took.
Replacement, which means if you have selected a card, okay, and you are keeping it back, so that is replacement. Okay, you are placing it back. Without
Back in
replacement,
deck.
yeah, you are placing it back. So if you have 52 cards in total, okay, and you are drawing 2 cards, suppose, okay, and with replacement, which means you have put the 2 cards again in that pack of cards. In the next row also you have 52 cards, because the cards that you have drawn earlier, you have put it back. That is with replacement. And without replacement, which means once you have drawn a card, then you will not keep it back into the pack of cards. Okay, so if in case you have drawn 2 cards out of the 52 cards, then in the next draw, for the next draw, you will be having only 50 cards. Okay, because you have already taken 2 cards. That is without a replacement. Anything else? Okay, then we can end the session.
Okay.